Hey, happy Tuesday, ladies and gentlemen. Hopefully, everything's going well on your end. Today, ladies and gentlemen, we shall continue working with coding, specifically with while loops. So, we'll run through three, four, maybe even, I don't know, maybe 5 levels of the while loops just so you feel supported. And then I'll cut you loose with that. You're not going to have to upload anything for while loops. But while we're discussing uploading, about half the class did upload the conditional code and the for loop screenshot. I appreciate it. A lot of 15s out of 15s, 14s out of 15s, really good scores. But about half the class didn't upload anything. It's really hard for me to give you a solid grade if you don't upload anything. So if you haven't done so, this has to take priority today. Upload your screenshot for loops and conditional code. All right, let's do this thing. Sorry about that spring, ladies and gentlemen. I am on while loops, specifically running code while ... What a while loop is, it's similar to a for loop, only it's constantly running. Think of it as like an infinite loop. So in this instance, if we look here, what do we need byte to do? Well, we need byte to move forward and toggle a switch, or actually the other way around if we look at it, because byte's on a switch first. So we're going to use a not operator that we learned yesterday. So I'm going to hit shift exclamation point. Recall that means not. While not is blocked, so while the forward motion is not blocked, what do we want byte to do? Well, if byte is on a closed switch, we want byte to toggle the switch and then we want to get out of our if statement but still be in the while. We also want byte to move forward. So let's look at that real quick. While not blocked, if on a closed switch, toggle it and move forward. So we're going to run that as fast as possible. Hopefully that compiles quickly. As long as those conditions are met, byte should do what we told. Holy moly, that's a lot. It's a good thing we used a while loop. Sweet. Okay. The next page, actually, the code is really no different at all. In fact, I wanted to have that deleted. I apologize. So let's look at it. Even though the level looks different, what's byte need to do every time? Well, byte needs to move forward when it can. So when not blocked, check. We want byte to move forward, and then if byte is on a closed switch, we want byte to toggle that switch. Okay, so let's look at this one more time. While not blocked, move forward, and if on closed switch, toggle the switch. This sure looks good to me. So we'll run that as fast as possible. Hopefully it compiles properly. Sure enough, good to go. Okay. Once again, a while loop is a loop that runs continuously. You don't have to tell it, how many times to run through. Here, if I recall, ladies and gentlemen, you have a function already provided for you. I forget the name of it, so forgive me. I'm just going to call mine pattern because it follows the pattern that byte has to do here every time. And if I recall, forgive me, because I go through, I do these levels and then I delete the answers to make these YouTube videos. If I recall, The pattern was already provided for you, but we'll talk about it nonetheless. So what does byte need to do in our pattern? Byte needs to move forward, check, turn to the left, move forward, collect a gem, and then turn to the right. When byte does that, forward, left, forward, collect, right, byte would be facing the same orientation. So there's our pattern. So while, once again, we're going to use not blocked, so shift exclamation point is blocked. Recall, exclamation point is blocked means not blocked. What do we want byte to do? We want byte to run our pattern. So I'm going to select the word pattern. Once again, if your function's called something different, because I believe it is, you would have whatever that name is there matched up there. Okay. And as long as I recalled our pattern, we should be all right here. Big if. So far, so good. Once again, while loops super handy when doing programming, because instead of telling it how many times to run this loop, it will go on infinitely until the condition is no longer met. Okay. 4x4, it's another while loop, big surprise, but we have to think about it, a little more critically. So what do we need byte to do? Well, while once again not blocked, we need byte to move forward. Check. If byte's on a close switch, we need byte to open that switch, or toggle it, I should say. Okay. And if byte is on an open switch, aka one that's already glowing, we need byte to turn to the right. You're saying, why, Mr. Herr? Well, let's think about it. Move forward, move forward, move forward, check. Is on closed switch, turn that switch on, then that switch is open, and byte will turn to the right. Then move forward, move forward, move forward. I like it. Let's see if this compiles and runs as smoothly as one will hope. If so, then we'll knock out one more level, ideally. Look at that. Lucky beats good, kids. Sweet. Okay. The next one, which I believe turned around, that's it. This one's more complicated because you have to think a little more, what do we do here in every situation? Okay. So if we look here, we have a lot of stuff going on. So it says we could do a while loop, a for loop. I ran through this numerous times, and I'll give you a little heads up. If we run a for loop, specifically 11 times, it works out really well. So what do we need byte to do? Well, we need byte to move forward. Check. Okay. If byte is on a gem, we need byte to collect that gem. Okay. Check, check, check. So far, so good. But then what do we need to do? Well, if in front of byte is blocked, we need byte to turn to the left. Check. It's blocked, turn to the left, check. Then it'll move forward again. Okay. It'll collect that gem, but then it's blocked to the left. It's blocked in front, and it's blocked to the right. So if is blocked front and is blocked to the right, well, what do we need byte to do? We need byte to turn left. But that's not all. Last but not least, that gets byte to that center section there. We need byte to, if it is not blocked, to the right. So if not blocked, and I know this is big time thinking, is not blocked to the right, we need byte to turn right. So let's look at that code. Man, that's a lot. Okay. I'm not sure actually if I need that is blocked and is blocked to the right, come to think of it. I think that's a little redundant, so I'm gonna delete that. If I'm wrong and we have to recompile it, I apologize in advance. One thing about coding, a lot of times you're not right the first time. Trust me, I do this all the time. Look at that. Lucky beats good. Okay? Hey, that's about a 12-minute video. Keep working on while loops. See you later. Peace.